This is part 6 of the module 6 lecture. In this case, we're going to learn to find either a z-value or an x-value from a given probability. So in this situation, this type of problems, we've asked to find an x-value for a given probability. Like in this example, the probability that the random variable is less than some number is 0.01. But the question here is, well, what is this number? And in general, in these problems, I deal with normal distributions, and we're given the mean and the standard deviation in every case, so that we can find that x of 0 value. So the procedure to find this x of 0 value consists of 3 steps. Number 1, find the probability that you're given on table 4. Then once you find the probability on table 4, then you find the corresponding z-value. Once you have the z-value, then you use the mean and the standard deviation of that x random variable, and then you find the x sub 0 value using the z sub 0 that you found. So this is the formula that we use to find x sub 0. And once you find the x sub 0 value that you've been asked for, then you interpret that number. And here I'm sketching the normal distribution where I'm showing that the probability that is given, and of course that's equivalent to the probability in the z-scale. And here I reverse the scales. I have the z-scale on top and the x-scale on the bottom, because since we're using table 4, which gives us probabilities from a standard normal distribution, is going to give us a corresponding z-score. And so once you find the z-score, then you find the x value for the x random variable. And once you find that value, then you interpret it. Now here I'm providing the formula that you can use in Excel to find the x value directly without having to go through the standard normal distribution, in case that you want to try and see how that works. But I'll let you do it. If you have any questions, let me know. But for our purpose, we're going to follow this 3-step procedure, and that's what you're going to be asked to be done in your homework assignment, or in quizzes, or in exams. All right, so let me now with this example illustrate the mechanics of how this is done. All right, so the random variable x is normally distributed with mean 35 and a standard deviation of 7.5. And they're asking us to find the x value for a probability of 0.695. All right, once you see this probability, then you go into your table 4, and then you find that probability in the body of the table. So in this case, because 0.695 is larger than 0.5, you know you're going to find that value on the second sheet of table 4. So in these numbers over here, and what I did, I just copied part of that table 4. And so if you pull your table 4, you will see this, the second sheet of table 4. So once you find the 0.6950, then you see that on the rows it corresponds to a z-score of 0.5, and in the columns to a second decimal place of 0.01. So the z-value that corresponds to a probability of 0.695 is 0.51. So once you find the z-value, then you use this equation. So you take the mean plus 0.51, the z-value that we found from the table, and we'll multiply that z-value times the standard deviation, and that gives you the x value. Once you have the x value, then you interpret that result. So here we can say that there is a 0.695 probability that the random variable assumes values smaller than 38.825. So again, this illustrates the use of the 3 steps to find the x value. All right, let's look at this example. So in this example, scores for a civil service exam are normally distributed with a mean of 75 and a standard deviation of 6.5. To be eligible for civil service employment, an applicant must score in the top 5%. The question is, what is the lowest score an applicant can earn and still be eligible for employment. So we're looking for the lowest score acceptable. All right, so using that information, then we're gonna put it on this other slide. And if we were in class, in a live class, I will, on the blackboard, I will then copy this information onto the blackboard and explain it as we go. But there's no blackboard here, so what I'm going to do is put it on the next slide. So in here, the random variable x is a score on the exam. And the random variable is normally distributed with a mean of 75 points and a standard deviation of 6.5 points. So the probability of an exam score in the top 5% or 0.05 means that we're looking for scores that are in the top 5% of the distribution. That is, we're looking for values larger than some minimal score so that the probability is 0.05. So now, remember, table 4 always gives you probabilities to the left of the value. So in this case, the probability that we're looking for is the probability that x is bigger than x of 0 is of 0.05. But that probability is on the right side of the distribution. That will not give us the z-score that we're looking for, because the table 4 only gives you probabilities to the left of that value. So to find that value, we're going to use the complement of this probability that the random variable is bigger than some value equal to 0.05. Since the total area under the curve is 1, the complement of this event, of course, is that the probability of 0.95, and that is the probability that the random variable is less than some value x of 0, which is the one we're looking for, is the same value. So in this case, we're going to use the probability of 0.95 to find the correct value x of 0. If you do not do this, and you just go into table 4 with a probability of 0.05, then what you're going to find is going to be the x value for a probability of 0.05 to the left of that value. And that's going to be a very small number. And that will be the wrong number. So remember, you're looking for this number, and so to find it, you need the probability to the left of that number. And in this case, to find it, you must use the complement. All right, once you have determined that the actual probability to use to find this z sub 0 and this x sub 0 values is 0.95, then you go on table 4 and you find the corresponding z value. Now, if you look through your table 4, on the second sheet of table 4, you're going to see that there is no 0.9500 value on the table. The closest values that you find is 0.9495, which is just 0.005 units below it, and that corresponds to a z of 1.64. And the other closest value to 0.95 is above it, and that's 0.9505, which is 0.0005 units above it. And that corresponds to a z-value of 1.65. So as you can see, 0.95 is right between these two numbers, right in the middle, because it's 0.0005 units above this number, and it's 0.005 units below this number, so right in the middle. So to find the corresponding z-value for 0.95, we just take the average of these two z-values, as I'm showing over here. So the z-value for a probability of 0.95 is 1.645. So now that we found the z-value, then now we use this formula and find the corresponding x value. So we use the mean of this distribution, which is 75, plus the z-value that we found, times the standard deviation, and that gives you 85.69. So this is the value we're looking for. So now we need to interpret it. So this number represents a minimum score to be eligible for civil service. And because they're using integers, so we will say that the minimum score to be eligible for civil service employment is 86, because we round it up to the closest integer. So this is problem 2. Let's look at another problem. In this problem 3, it's a little closer to my heart because I used to work for Texas Instruments, And I remember all the problems we had with their calculators. They were terrible. Well, I'm talking to you about 40 years ago. Now they're excellent quality. All right. It is known that a life of a particular type of calculator has a normal distribution with a mean of 54 months and a standard deviation of 8 months. So the question is, what should the warranty period be to replace a malfunctioning calculator if the company does not want to replace more than 1% of the calculators? That is, they want to replace less than 1%. Right, so of all the production, you want to at most replace that 1% of calculators that have a much shorter life. All right, now let's take this information and interpret it over here. So the random variable x is the lifetime of a calculator, and it is normally distributed with a mean of 54 months and a standard deviation of 8 months. So the requirement that the company does not want to replace more than 1% of the calculators corresponds to finding the largest lifetime of the bottom 1% of the calculators produced. So the probability they are giving us is the probability that the calculator will last less than some maximum lifetime, so that is only 1% of all calculators produced. All right, so now here's how we found the probability that we need. So we follow our three-step procedure. So once you have the probability, you go on table 4 and you find for the probability of 0.0100. And it's in the previous example, well, you don't find it. What you find, the closest values to it is 0.0102. That corresponds to a z-value of minus 2.32, and 0.0099 that corresponds to a z-value of minus 3.33. So if you look at these two numbers, this 0.0102 is 0.0002 units above it, and this is 0.00001 units below it. So in this case, instead of finding that or do what is called interpolation, we just simply say, well, since 0.099 is the closest value to 0.01, we take that as the z-value for 0.01. So in this case, because it's not right in the middle, we take the z-value of the closest probability to the probability that we're looking for. So in this case, we're going to say that the closest probability is 0.099, and then we're going to use the z-value of minus 2.33. So once you have that z-value, then you plug it into this equation. So here's a mean of 54 months plus the z-value minus 2.33 times the standard deviation of 8 months. If you carry out this calculation, you find an x value of 35.36 months. So now that we have the x value, we need to interpret it. So in this case, we'd say that the recommended time for the warranty should be at most 35 months from the update, from the date of purchase, which is pretty good. I mean, this is almost 3 years. All right, so this is the last example. Now you've seen a few examples of how we can use a normal distribution to find an x value, a value of the random variable x. In the next section, we're going to talk about approximating binomial probabilities with a normal distribution.